Okay, welcome back, CIS 257. This is officially, I think it's week 5 that we continue with our material. The latest postings here on the website, as you can see, there's a new quiz, and there's also assignment 3, which is definitely something worth looking at today. I plan to overview assignment 3 and its challenges as we continue covering our material, our current material, primarily focusing on the rest of the topics related to class inheritance in Java, number 1, and number 2, we're also going to talk about certain aspects of definitely object-oriented features of Java programming language, which will include abstract classes, abstract methods, and also interfaces. And we are also perhaps need to address the issue how those features are actually directly helpful in the way we can implement our code, our applications. So let's get started. First of all, I'm going to look at my course outline here, and we have some unfinished business in the inheritance presentation, so this is where I'm jumping first. We've briefly talked about inheritance syntax, and we also had some conversation earlier that we said that the methods are not really contributing to the size of our objects when classes are used and objects are instantiated from these classes. The class size really does not depend on the number of methods that our classes contain. However, all data fields, all data attributes that we add to our classes do contribute to the size of our objects. And clearly, knowing the sizes of our objects can be very important, especially if you know that you have to create 1,000 of objects. It kind of helps to realize what really contributes to the size of your objects. So we're going to go from there, and we're going to continue illustrating those related topics to the issue of the sizes of our objects and the actual runtime arrangement of any kind of polymorphic behavior that we're going to cover today. So, but a few technicalities to begin with. So number 1, for example, in Java, there is a class named class with the method named getName. And so it's kind of a strange name for a class named class, uppercase C. But nevertheless, as we know that, let me just resize this a little bit so that we can see the usefulness of the class method. As you know, when we create our classes actually inherit from the object class. And the object class does contain a getClass method. And so getClass method returns back an instance of a class object, and that class object has a name, and therefore when we have an instance, when we have a reference to an object such as this product P, which is instantiated as in this particular sample as new book, right? We can ask this class a particular instance of this class. We can ask whether what is the actual name of the class. So I assume that in this example, what happens is that, in fact, we can perhaps give it a try and run a quick demonstration of this. But as my NetBeans is loading, I will just keep moving forward with this talk here. So I'm assuming that Product is a superclass. Book is a subclass. So book is a specific product. And when we say new book, it's fair to remember the reference to this particular object as the type of product, right? Because book is a specific kind of product, so therefore remembering the reference to this book as a product object reference is perfectly fine. And then you can still recover and find out what is the actual class by going to your object interface, saying get class, then using the class object, which sounds really strange, use its get name method, and get name method returns a string with a class name. So then you can say compare it to the book, the name of the class at runtime, and as you can see, this is likely to print that this is a book object. However, P itself, this specific object reference, is the type of a product. But since the original object was created as a book, you can still get to that point and find out what this is. There is an alternative to this, which we're using the instance of on the right-hand side of this side-by-side comparison, which I think is more effective and it should be preferred, but at least we need to be aware of the presence of the class in Java API, and object class, which every single user-defined class that we define inherits from, whether you want it or not. It's a given that it does inherit. So let me see if we can run a quick demonstration of this specific behavior.